What makes us special as humans is we're aware of our mortality. We know we will die. Ever since we became aware of this, we've been trying to solve the death problem. It plagues us, haunts us, and ultimately spells the end for every one of us. We've been successful at distracting us from this reality. With religion, for example, you can believe we live on eternally in heaven. But now it seems we are the gods. Now we have the potential to edit out the flaws, bringing on our sickness and death, and tinker with our DNA to extend our longevity into centuries. And it has come in the form of a major genetic engineering breakthrough. It's called CRISPR. The technology is moving so fast and the possibilities are so massive, we're stuck with an ethical dilemma of whether this should be something worth experimenting with, or we should pause and give the potential consequences more consideration. We catch up with genetics expert and founder of Eugene, Kunal Kalro, to see what is happening on the front line of the research. What's been the kind of the hallmark case where that dilemma of going around and round when it was concluded, and how was that concluded?
It hasn't happened yet. Yes, we're going to go round and round in circles for a while, but maybe we should, because this technology is moving way faster than our ability to comprehend the ethics of it all, and our ability to actually navigate the ethics of it all. We're going to be at a point sooner at a point where it might be possible to it's already possible to genetically edit an embryo, right? But the ethical quandaries around that is something that's going to take a lot longer to overcome. We're making decisions not just for our children, but like our children's children. And that kind of power is not something that we're well equipped to deal with. I think it'll take inequality to a tipping point from which we might never return.
And Jason Silva thinks this is just the beginning. Once we take the exponential advancement of computers, what are the possibilities?
The supercomputers of yesteryear are in everybody's hands. A young person with a cell phone in Africa today has better communications technology than the US president had 25 years ago. So consider what that means. So it used to be half a building, now it fits in your pocket. In 25 years, it'll be the size of a blood cell. It'll be reverse engineering us from inside. Computers trillions of times more powerful than the ones we have today will be inside of our bodies. I'm trying to get into the implications of what's happening on the back of these exponentially emerging technologies. When we reverse engineer life itself, when biology becomes the new canvas for our aesthetic design, what new forms of genius might come out of that?
My name is Tommy McCubbin, creative director, dad and podcaster, and this is Future Sandwich, episode 15, CRISPR's Consequences, the genetic engineering breakthrough that puts the power of God in our hands. Now let's start at the beginning. I first properly heard of CRISPR featured in one of my favourite podcasts, Radiolab.
This is Radiolab. I'm Jad Abumrad.
I'm Robert Krulwich.
All right, so let me explain to you how I got started with this.
You were some kind of an affair?
Yeah, so I'll tell you how it got. I was at a party. It was a conference where they had a lot of different people of different disciplines come together. You know, one of those. There are panel discussions of various things. And so we were at one of the functions, and it was a situation where dinner hadn't yet been served, and there was a lot of booze being served, so everybody was drunk on an empty stomach. So I was standing there with some biologists.
Oh, they're the fun ones, the drunk biologists. Yes,
as my people apparently, and they started to lose their shit, genuinely lose their shit about this thing called CRISPR. And I have never seen scientists this excited about anything. So I was like, what is this thing? What is CRISPR? And they were trying to explain it to me, but they couldn't slow down enough for me to get it. I gathered it had something to do with genetics. And then at one point, one of the biologists turned to me and he was like, I'll tell you what it is. I can use CRISPR to take a little dog and poof, make it into a big dog. Give me a Chihuahua, I could turn it into the size of a Great Dane. And I was like, no, you can't. He's like, yes, I can. I could do it with CRISPR. I was like, what the hell is this thing?
So CRISPR is a technology that allows us to edit our DNA. If there's a flaw, we literally program molecular scissors to target that flawed part of the genome, slice it out, and replace it with anything we want. We could continue to go deeper into the technical description of how it works, but it's more fun to let this video produced by Wired help us out. This is Neville Sanjana, a biologist at New York University and New York Genome Center, explaining CRISPR to a teenager.
Do you know what CRISPR is?
Absolutely not. No, not
Okay.
at all.
CRISPR is a way to edit the genome. Do you know what a genome is?
Yeah, it's the DNA.
DNA is kind of the language that the genome is written in. And the genome itself is an instruction manual that describes how to make you, how tall you should be, what color hair you have, or what color eyes you have. So what CRISPR is, and an easy way to think about it, it's like a molecular pair of scissors that can go through that long, long genome and find specific places, make small cuts, and edit it. What do you think about being able to edit genomes?
It's actually kind of cool because then you could change, can't you technically change things about a person if you edit the DNA?
Sure. So how do we determine what's the right uses then?
I don't think it should be used for almost cosmetology reasons,
Okay.
or like for people just to be like, oh, I want to be 5'6" instead of 5'4", or like reasons that aren't necessarily the most important. I just think if it could genuinely help someone, like if someone had cancer and there was a way to fix it or like slow down the growth.
So a lot of the work that we do in my lab is about being engineers of DNA. We try and look to see what mutations cause diseases and to see if when we change those mutations, if we can take a sick cell or organism and make it healthy again.
Couldn't you technically, because the P53, when it's defected, that's what causes cancers.
P53 is the most common mutation in cancer. That's right, yeah. That's a great idea, actually, to use CRISPR to target tumor cells and restore P53, to fix that mutation, so to make that cut with these scissors and fix it.
So this is life-changing technology. Our special guest, Kunal Kalro, is founder of Australian company Eugene. I sat with him as Melbourne's trains screeched by to discuss the good, bad and the mind-blowing potential of CRISPR.
Yeah, so I'm Kunal Kalro. I'm an entrepreneur. This is my third company at this stage. I don't like the word serial entrepreneur, it makes it sound very douchey. But I've started companies in the past, and that's what I do. I love doing it. This is my third one. I started Eugene originally because, well, after my previous company, I wanted to work on something that mattered and could create positive impact. Started exploring genetics and eventually figured out that there's huge accessibility issues and disparities issues health disparities and health outcome disparities between different racial groups and different people, primarily because there's a huge lack of ethnic diversity in genetic data. So that's why I started Eugene. Yeah. So the premise of Eugene, so why we started Eugene was so that we could help address the lack of ethnic and racial diversity in genetic data that was used in healthcare research. And like you were saying, the main reason why this lack of diversity exists is because most people that have been screened so far are primarily socioeconomically wealthy in Western countries, which results in primarily Caucasian. And as a result of that, most of the data that entered the research market was through those channels, and it was primarily Caucasian. And this plays out fairly negatively for everyone else. Primarily, the three main areas where this plays out really badly is regulatory standards that are set. So, for example, if you're a black man or a black woman, you're much more likely to die of prostate cancer and breast cancer than if you're not. So using prostate cancer as an example, one of the main reasons that's the case is because the regulatory body suggests a gold standard prostate cancer screening test that is much less likely to detect the type of prostate cancer that black men are more likely to get. And that type of cancer is also far more aggressive and far more lethal. So they don't get the benefit of early screening because the type of screening that the regulatory bodies have recommended don't really detect it. And the reason why the regulatory bodies recommends that test is because the data that they use and the research that they used to create a gold standard test hadn't included that much in terms of data from black people, and as a result they didn't realize that that type of cancer was even common in different population groups. So it's not like anyone was doing that on purpose, it's just the lack of data creates solutions that become far more focused for certain ethnic groups and not others.
So how long have we been editing genes for?
We've been trying this for a very long time. So genetic editing is not a new concept per se. Think about gene therapy, and it's been in research as long as we've known that genes exist. As soon as we figured out genes exist, of course, we wanted to change them.
When was that breakthrough?
When do we discover DNA? I have no idea. I'm not gonna lie. I actually don't know the exact date. We were able to sequence for the first time a human genome. I think it was 2001. But that was full sequencing, and it cost us like $1 billion or something. It was very expensive. Today, sequencing costs $1,000. So the drop has been pretty dramatic. But in terms of the original discovery point, I couldn't tell you. Yeah, it's been a long time. And so we've been in this area for a very long time. But up until the discovery of CRISPR, it's been very hard and very expensive. So before CRISPR, it was incredibly difficult and incredibly expensive. CRISPR has just made it a lot less expensive and only incredibly difficult. So like two less incredibles. It's still very hard. So let's not to do it right, it's very hard. The human genome has 3 billion base pairs. If you want to go and change 1 or 2, CRISPR can help you do that. But how do you know it's not going to change anything else? And making sure that it doesn't change anything else, the whole thing around unintended consequences, is very difficult. There's 3 billion base pairs. It's very complicated. We've been in this market, and we've been in this industry trying to make this happen for a very long time. CRISPR has just given us the tools to make it much easier and much more affordable. Still hard, still very hard, but relatively much easier.
The potential, the game-changing application, or one of the applications of CRISPR in the real world, which has potential now.
Sure. Okay. Basically, CRISPR is find and replace, your Microsoft Word find and replace for DNA, and goes across all organic material. There's huge health applications. There's huge agricultural applications. Pretty much everywhere. So some interesting areas. There's a genetically modified mosquito that exists that has been edited to alter its gene drives, which means that if they release this mosquito in a specific native habitat, they could eliminate that entire species of mosquitoes. Or significantly, at the very least, significantly reduce its propagation. You could basically eliminate malaria using this. The only question is, should you? So
that's just on that.
Yeah.
Unpack that sort of dilemma.
One is, the biggest question is, of course, unintended consequences. It always goes back to that. What happens in the broader, upstream ecosystem if we do something like this? We don't know, right? Mosquitoes are part of an ecosystem and a habitat. If we eliminate that particular species or breed of mosquitoes, then what happens? Bats eat mosquitoes. Does that make bats go extinct too? What? Does it go up the chain? We don't know. And so that's a big question. Also, who gets to decide? So a lot of these ecosystems across national borders, across in countries where, obviously if such mosquito was to be released, it would be primarily in areas where malaria is of high incidence, right? So we're talking about parts of Africa, and let's use parts of Africa as an example. We have to go, we can't decide. We can't go in there and be yeah, we're gonna do this. We're gonna completely and drastically alter the ecosystem that's here. It's not ours. We don't get to choose that. So then we need to go and ask the local communities if they would like to, have this happen. But as any part of informed consent, they need to be informed, and they need to be able to understand what they're consenting to. So you can't just be like, hey, we're gonna eliminate malaria, and they were like, yeah, sweet, but you need to explain that, oh yeah, cool, like what we're actually doing is this genetically modified mosquito that is going to that's been altered, and the gene drives have been altered so that, the mosquitoes will no longer be able to reproduce at the rate that they were, and as such, eventually die. So even explaining what DNA is in many communities, like it's not a term that exists in many languages. So how do you do that? So yeah, there's lots of ethical quandaries. Whether or not we should do it, but also who gets to decide is the main question.
We could go, like, society could go around and around in circles on that forever. Is it kind of, are we reaching a point where we're approaching that dilemma better, or is there a case where it was where it has been done successfully, where the conclusion was reached, where that dilemma?
In the case of mosquitoes,
yeah.
No, not yet.
What's the sort of what's been the kind of the hallmark case where that dilemma of going around and round when it was concluded, and how was that concluded?
It hasn't happened yet, is what I'm saying. I don't think so. It's new technology, and the broader population in most countries don't really know the significance or even understand the significance of what we're talking about here yet. And I say yet, because it will come. But that education needs to get up to scratch before we can actually start making such choices. Yes, we're going to go round and round in circles for a while, but maybe we should, because this technology is moving way faster than our ability to comprehend the ethics of it all, and our ability to actually navigate the ethics of it all. We're going to be at a point sooner at a point where it might be possible to it's already possible to genetically edit an embryo, right? But the ethical quandaries around that is something that's going to take a lot longer to overcome as a society. I just don't think we're there yet.
There's reports like China have been pushing this and doing some tests on humans.
Yeah.
What was that test about? How did that, how is that so revolutionary?
Well, I would say firstly, it's not just China. The US did it as well.
Yeah.
And so the US actually, a few months ago in Portland, they were able to successfully edit a human embryo. And when I say successfully edit, it means that there were no unintended consequences. So they were able to successfully go in and replace a gene. So it was a faulty gene that caused HCM, hypercardiac myopathy, which means that your heart can stop at any time. And so obviously that's like a genetic condition that if anyone has in the family, they would definitely not want to pass on to their children. And so they were able to successfully edit the DNA of a human embryo with no unintended consequences that they could tell. But of course they didn't bring the embryo to term, right? We're still in a very experimental phase. But the US has done it, China has done it, China did it earlier in the year as well. But they weren't able to do it as successfully, quote unquote. So it's not just China, the US is doing it as well. China is forging ahead in this space, and I don't think that there is a lower, I don't think there's a lower barrier of ethics, right? Like, the way that we think about, this research is happening everywhere. How people feel about this research is based heavily in the ideologies that they've grown up with, right? In Western countries, we like to believe that we're quite secular, but to say that we're not influenced by religion would, in my personal opinion, be an inaccurate statement. You think about why people feel uncomfortable with genetic editing on human embryos, but they don't have as much of a problem with agriculture or something like that. What is it? Oh, it's ooh, I don't know why I feel weird about this, but I feel weird. Yeah, let's unpack as to why that is. We know that a lot of religions would not necessarily support human DNA editing because it's like quote unquote playing God. But that doesn't mean that from like a scientific research perspective it's not happening. It's happening everywhere. Just how people feel about it is different, is what I would say.
So what would nightmare scenario look like?
Yeah, good question. In human beings, the nightmare scenario, in my personal opinion, is there's a few. First, so at some stage, the first human being will be born that has been genetically modified in some way, right? The thing is, there's no like pull back button. There's no like, ooh, we take that back, sorry. Once that happens, this person enters the pool of human beings that reproduce and propagate and pass on their genetic data, right? So we make decisions not just for the parents and like, you know, the doctors that they work with to make this happen. Make decisions not just for themselves, but for their child, but also for their child's child and their child's child, and so on and so forth. So what gives us the right to make decisions for an entire generation of human beings in this very, very, very specific way? And while it might be an easier ethical choice to make if it's just weeding out a specific genetic disease or disorder, and especially if that disease or disorder is incredibly stifling and like could potentially lead to death in like in a very early age for the child, that becomes an easier choice. But when we start, but the same technology can be used for anything else, including enhancement, right? So, so what happens when we decide that we value intelligence above everything else, or we value creativity above everything else, or we value beauty above everything else, and all of those traits that would be like, you would be able to like use the same technology to make all of that happen, then we're making decisions not just for our children, but like our children's children. And that kind of power is not something that we're well equipped to deal with, is what like I personally believe, at least at the current moment. So nightmare scenario in that case is that we're barreling down a future society that maybe is not for the betterment of the greater like civilization. And the second aspect of that is that these services are going to be quite expensive to start with. So there's going to be huge levels of inequality in terms of access to these services. And so today we have like a huge degree of social inequality and like socioeconomic inequality, right? People who can afford better healthcare get better healthcare, and people like who can afford better education get better education. And that privilege is already dividing us to a very, very, very difficult degree. In the future, if they also have this genetic privilege, right? Up until now, it's like we all play the genetic lottery. We reproduce the old-fashioned way, and you know we don't know what we're gonna get. It's a lottery system, and that was one of the only things that was like still left to chance. If we take away that chance, then we add genetic privilege in a group of society that has access to these services, and another group that doesn't. So what happens when you give genetic privilege to the people who have economic, social, political, and educational privilege already? What happens to that gap? And is that gap something that we would ever be able to overcome? I doubt that. I think it'll take inequality to a tipping point from which we might never return. And that will create two subclasses of society, two subclasses in society, and you know, we've all watched Gattaca. I think that's like a pretty easy nightmare scenario. I can see that happening pretty easily. I mean, it's already, yeah.
Kunal opened my eyes to what the very real risks are if we tinker with our DNA. But what does this look like through the eyes of the ever-optimistic philosopher, Jason Silva? This is him at the Festival of Dangerous Ideas in Sydney, on how the exponential growth of technology is heading for a world that looks more like an acid trip than reality.
My friend Ray Kurzweil, who's a world-famous futurist and has an amazing track record at predicting these exponential changes, he uses a famous example. It's really simple, but I think it's important that people take it in order to understand what makes this kind of radical change possible. And he says, take 30 steps. If you take 30 steps linearly, you go 1, 2, 3, 4, 5. 30 steps later, you get to 30. That's pretty simple. That's how our brains make extrapolations about distance and about what's coming and about the future. Now, if you take those same 30 steps, but you take them exponentially, you would go 2, 4, 8, 16. 30 steps later, you'd be at 1 billion. That's the difference between linear growth versus exponential growth. 30 steps, 1 to 30, 30 steps, 1 to 1 billion. And that accounts for the reason that the cell phone in one's pocket today, the average smartphone, is 1 million times cheaper, 1 million times smaller, and 1,000 times more powerful than a supercomputer that was $60 million, half a building in size, 40 years ago. So what used to be half a building now fits in your pocket. So the tools to change the world are in everybody's hands. The supercomputers of yesteryear are in everybody's hands. A young person with a cell phone in Africa today has better communications technology than the US president had 25 years ago. This is also out of Peter Diamandis' book, Abundance. So consider what that means. So it used to be half a building, now it fits in your pocket. In 25 years, it'll be the size of a blood cell. It'll be reverse engineering us from inside. Computers trillions of times more powerful than the ones we have today will be inside of our bodies. You talk about the coevolution of humans and technology. People think technology is this separate artificial thing. It's in symbiosis. It's a who and what we are. It's a part of who and what we are. And eventually, we're going to close the loop because the technology is going to go inside of us. I'm very excited about the 3 overlapping revolutions we're seeing. Obviously, information technology, piggybacking on Moore's law. The computers get faster every 2 years, twice as powerful, half the size, et cetera, et cetera. They're shrinking. Then we also have biotechnology. Biotechnology means mastering the information processes of biology, understanding that our biology is software, and that software can be upgraded. Just like we upgrade our iOS on our iPhone, we're going to be able to upgrade our biological software. The famed futurist Juan Enriquez says, you know why this gets really exciting? Because when you can master the information processes of biology, you have software that can write its own hardware. Computers could never do that, but biology can. We had the world's first artificial organism created a few years ago by Craig Venter. Man creates life. Man becomes God. Alan Harrington wrote a book called The Immortalist, where he says death has become an imposition on the human race and is no longer acceptable. And any philosophy that accepts death must itself be considered dead, its questions meaningless, its consolations worn out. Perhaps these technologies are our rehearsal. Perhaps by reverse engineering life, we have decommissioned natural selection, as Edward O. Wilson says. And now we get to look deep within ourselves and decide what we wish to become. Evolution has woken up. Evolution has evolved its own evolvability. As Kevin Kelly said in that video, we're on a trajectory smack in the middle between the born and the made. Man is a bridge and not an end. The other revolution we're seeing is in artificial intelligence. We create non-biological intelligence, sentience that is not limited by the inherent limitations of biology, digital minds that can be endlessly upgraded. And people worry about it, right? They think the Terminator scenario because they're like, oh, those things are going to take over. But those things are us. They're us. The cognitive philosopher Andy Clark says we need to get over our skin bag bias, which is this assumption that's only what is within our tissue that is natural and that what we create is somehow unnatural. But that's not true. Technology is an outgrowth of the human mind. Technology is imagination made manifest. Technology is psychedelic. The word psychedelic means mind manifesting. Terence McKenna says we live inside of condensations of our imagination, and we really do. Somebody dreamed of flight. Now we fly in aircrafts all over the world. With our smartphones, devices made of plastic and metal, we punch a few buttons and we send our thoughts through time and space, transcending time, space, distance. We're gods. I'm trying to get into the implications of what's happening on the back of these exponentially emerging technologies. When we reverse engineer life itself, when biology becomes the new canvas for our aesthetic design, what new forms of genius might come out of that? As Kevin Kelly said in my first video, right? How impoverished would this world have been were it not for the invention or the technology of the oil painting allowing Van Gogh to unfurl through it? What new genius will come out with inventions we cannot even conceive of yet? And people worry about disruptive technologies, they worry about their jobs. Half the jobs that exist today didn't exist 50 years ago or 100 years ago. Most of the jobs that are going to exist 20 years from now don't exist today. What new forms of artistry, what new forms of human expression, what new occupations and vocations will emerge out of these tools and our ongoing coevolution with these tools?
CRISPR is the key to the beginning of humankind properly extending our longevity. It has made editing our genes much more accessible, affordable, and within all of our reach. The current debate is a healthy one, and I have complete faith with people like Kunal leading the innovation, it will have a conscience. But CRISPR's progress won't be stopped and put on a shelf. If anything, it will be slowed down and attempted to be tamed. CRISPR will impact everyone soon, hopefully in a way that bridges the gaps of inequality, sickness, and disease. This wraps another episode of Future Sandwich, episode 15, CRISPR's Consequences. Thanks to Jad and Robert from Radiolab. Their episode on CRISPR is linked in the show notes at futuresandwich.com. Also, Wired and Neville Sanjana for explaining CRISPR like we're all teenagers. The full videos are also in the notes page. A big thank you to Kunal from Eugene. It's always a pleasure talking to you. The work you do is truly inspiring, and it's a privilege to have you on the show. Kunal's company is using genetic testing in a number of brilliant ways, mainly now in its pre-pregnancy genetic screening. It uses the latest technology with the best service available in the industry. You can find out more at eugenelabs.com. And Jason Silver, the human version of taking mushrooms, thank you for your words of wisdom. Find links to Jason's YouTube channel in the show notes, where there are more shots of philosophical espresso. And as always, thanks to Maddie Thompson for editing this like a boss. So Future Sandwich Live is happening again at BuzzConf Friday 1st of December. It's been described as Bushdorf meets South by Southwest, so of course we'll be part of it. We're opening on Friday night, so get your ticket and I'll see you down by the bonfire. You can get a discount on your ticket by using code special_Future Sandwich at the checkout. Also, Future Sandwich Live will be happening at PauseFest in February. Stay tuned for more on that. Tickets are on sale now at pausefest.com.au. And remember to follow Future Sandwich on Twitter, Facebook and Instagram. And give me a shout on Twitter at @TMcCubbin. Always keen to get your feedback on the show and where we take it next. And there we have it. See you next time.